Okay, guys, we can start. Please go to the page 144. Page 144. The topic is connect percent and proportion. The example one is to use a proportion to find the percent. The basketball team statistician tracked the shots Emily made and the shots she missed during the last game. What percent of attempted shots did she make? Okay. We can draw a bar diagram in the first and write a proportion to represent the number of shots made and the total number of shots. The proportion in this case, you have the blue part, is 9 shots, and in the red part you have 12 attempted shots. This is the 100%. So they want to know what percent of attempted shots did she make. Now, okay, we can solve the proportion. We have 9 shots made from 12 that are the total. This is equal P, that is the proportion. In this case, I have 1%. The percent, okay, and you divide this by 100. So maybe, I think that we can use again. Okay, so I'm going to use the board. For example, in the first one, you have this 9 equal P, and what we have below is 12 in here, 12 in here, and 100 in here. This is what I need to solve. Remember, okay, I have the radius. These are the radius, right? And I need to isolate for the variable P. So, for example, this 100 that is divided by variable, I need to pass it to multiply. So what we have in the next line? What we have in here is that I pass, for example, the 100 to multiply 9 times 100. This is multiplying. This is equal P. Okay, in the book, I'm going to show you. On the book, they use, for example, you have 100 in here. This is P, right? And you are dividing by 102, but it's because they multiply both sides of the equation by 100. Multiply this side and multiply the other side. But if you pass the number to divide, you don't need to write this one. Okay, you only need to write it in here, in this part of the equation. Now, if I insert the other number in here, is 12. What you need to do in here is to multiply the 9 by 100 and you divide by 12. And this is going to be the answer for P. So what number are we going to obtain when we multiply 9 by 100? 900, right? And you divide 900 by 12. So you obtain that P is equal 75. P is equal. Okay, these kind of examples are very similar to the examples we were solving yesterday. So I think that you are not going to have many doubts about this. For example, Emily made 75% of her shots. Remember, she was about to determine a percent. So this is 75%. Emily made 75% of her shots. So this is the way we use the ratio of part to whole describes a proportional relationship. You have the radius in here, okay, and you're going to have a proportional relationship. So if you have a proportional relationship, you can find the value for the variable you have in here. In this case is p. Only passing this number that is dividing to the other side to multiply. So I multiply 9 by 100 and I divide this by 12. So I'm going to solve with you the other example, the example below that says try it. And for example, Camila makes 2 of her 5-shot attempt. Is the percent of shots she made more than, less than, or the same as Emily's percent shots? Okay, we are going to use the same kind of exercise like the first one. You have the shots made, P is the percent, and the 100% are 5 attempted shots. So we find the answer in percent the same way like Emily's, and we are only going to compare if she has more attentive shots or Emily has more attentive shots. So I'm going to replace the numbers in here. This is 2 over 5. 2 is going to be equal, I'm going to write the equal in here. 2 is going to be equal P. This is the variable, right? And 2 is divided by 5. Remember, I'm talking about the number of shots. So 2 is divided by 5, and P is divided by 100. This is the percent, so you relate it with the percent. And the number of shots, you relate it with the number of shots. And I can draw in here, so you can see it as a fraction. And the same in here. So 2 over 5 is equal P over 100. How can we work in this exercise? We are going to pass the 100 that is dividing my variable to the other side to multiply. So if you can see, this is only one step. You multiply 2 by 100, and you are gonna say this is equal to P. Later you divide by 5. Okay. So what is the result when I obtain this? It's the same like we solved the first one. We multiply 2 times 100 and we divide by 5. When we multiply 2 times 100, we obtain 200, and 200 divided by 5 is 40. So I'm going to say that she made 40% of her shots. 40%. So what are we going to say? Camila made 40% of her shots. So when we compare, it's going to be greater than, less than, or what? If we compare 75% with, if we compare 75 with 40,
less.
75 is greater than, okay? So we can say that 40 is less than. We can write it in the opposite if you want, because they are asking you if the percent of shots Camila made. So we're going to change this to less. It's the same, okay? Only that I want to show you in the way the book asks you. The book asks you to appear Camila first because we want to compare Camila with Emily. So she has a 40% that is less than the 75% Emily made of her shots. So until this part, I think that is clear, this exercise. The procedure is the same like the other examples, only that they ask you one answer. You complete the answer depending on the percent. Now we can go to the example 2, page 145. Example 2 is in page 145. They are asking you to use a proportion to find the part. A plan to expand Megan's room will make the length of the room 175% of the current length. What will be the new length of her room? If we draw a bar diagram to represent the problem and write the percent proportion to find the new length, we are going to use the variable n for the new length, okay? So n is represented in meters. I have 175%, that is going to be the percent of the new length. And I have the 100% that was the old length, okay? This is the 100% of the room. So you can see the drawing. It has 3 meters and 4 meters of length. This was the 100%, and later they add 175%. It's almost, okay, the double of the length. So we are going to obtain this, the new length divided by the old length equal P over 100. What are we going to write in here then? I'm going to erase this so I can show you. What we have in here, guys, we have the new length over the old length. I'm relating the length, and later in the other side of the equation, I'm going to relate the percent. So I have in here new length. This is over the old length. This is gonna be equal P. P is the percent over 100. The percent, you already have it, and you already have the old length. So I'm only going to replace in here. I have the new length divided by the old length, and P is divided by 100. So what we need to do in here is to replace the correct values, okay? For example, you already know that the new length is going to be my variable n. This is going to be equal, the percent you already have it, is 175% of the original value, okay? The old length was 4 meters, okay? It was 4 meters, and now I use the 100% that was representing the old length. So what we need to do to find the value for the variable n, this value is what I want to find, the value for the variable n. So what I'm going to do is to pass the number 4 to multiply to the other side of the equation. That's the only thing I need to do. Okay, on the book you can see that they multiply in here and they multiply in here. They multiply in here because, for example, if you multiply the 4, when you divide 4, you divide this 4 with this 4, they are going to eliminate. You're going to obtain 1. But you don't need to do that. If you know what are you doing, you can pass directly the number 4 to multiply to the other side of the equation. So I'm going to say in here that n is going to be equal 175 multiplied by 4. Multiplied by 4, and this is divided by 100. So what is the answer when I multiply this and divide by 100? What is the number I obtain when I multiply 175 and I divide by 4 and I divide it by 100? Okay, and the new length is going to be 7. N is the new length and it's going to be equal 7. This is the new length for the room, 7 meters. We can write the units only, okay, to be sure that we know we are working with this, okay, meters. So the new length, N, is going to be 7 meters. This is the new length for the room, okay? Until this part, I think that you have it clear. So if you understand this, guys, we can continue with the example 3. On the example 3, we need to use a proportion to find the whole. The nutrition label shows the percent of the recommended daily intake for nutrients found in a serving of a soy milk. How many milligrams of calcium should you consume each day? We have the calcium per serving and the daily value. This is equal P divided by 100. So how many milligrams of calcium should you consume each day? Okay, we are going to try to solve this one. They change the variable. The variable in this case is not P. The calcium per serving is 260 milligrams. You have it on the drawing of the soy milk. The calcium is 260 milligrams. The daily value, we don't know the daily value. I want to know the daily value. This is going to be W. This is equal 20 divided by 100. In this case, 20 is the proportion, okay? In this case, I have the percent. This is a 20%. The calcium, the 260 milligrams is a 20% of the recommended daily consume. So we can solve this in this case. For example, I'm going to write everything like it's in the book. So calcium per serving, this is equal to P. This is divided by the daily value, and this is going to be divided by 100. Remember, 100 is the 100%. That's the reason why you have this divided by 100. I'm going to move this one. Okay. So this is the formula we have in here. This is the formula to obtain the daily value. Now I'm going to replace with the facts I already know. For example, the calcium per serving are 260 milligrams. You can see it again. You can see it on the drawing you have at the right part of the book with the soy milk. 260 is the calcium per serving. This is going to be equal P. What is P? P is the percent, and you can see that it's 20%. On the book they show you, this is the 20%. Okay, what else can I do in here? I don't need to write the percent, okay? I write it for you to see. On the daily consume, we are going to use the variable W. You can use, for example, the variable D. It doesn't matter, okay? Only matters that you are going to show how to obtain this value. And this is divided by 100%. Remember that the 100% is the total of this, okay? So the 100% is the total. You are going to obtain again the value of the variable But what can I do in this case that my variable is not up? Like in here, for example, my variable is W. I want to find W, but W is divided. So I want to find the value for my variable. I want to isolate. I'm going to show you what can we do. You have 260. And remember, I cannot have my variable divided. This cannot be on the denominator, because if my variable is in the denominator, I cannot obtain one value from my variable. So the first step I can do in this case is to pass my variable to multiply to the other side. For example, you have 20W, and this is also divided by 100. So my variable was divided, I pass it to the other side to multiply. Now you can see that my variable is up. My variable is up, so I can obtain one value. But in here, you see, now we have the equations like in the other examples that I told you to move the number that is divided to the other side to multiply. Because I want to have W alone. Maybe the procedure is a little long, but it's easier only to use the inverse operations. In here, I have 260, and I don't want this 100 divided my variable in here, so I pass it to the other side to multiply. This is equal 20W. Okay, but 20 is multiplying my variable. I don't want any number affecting my variable. No multiplying, no dividing, okay? So the number 20, I'm going to pass it to the other side to divide. Can you see it? I'm only trying to keep my variable alone. So in the next line, I'm going to write 260 multiplied by 100. This is going to be equal W, and the 20, the number 20 is in here dividing. What I want is to have the W alone. I want my variable alone. And this is what I'm trying to do, to keep my variable alone. Now I can obtain the value for the variable. I multiply 260 by 100, and I divide by 20. Can you see, we start in here with the variable dividing. We pass it to the other side because the variable cannot be on the denominator. The variable has to be on the numerator of the fraction. So I can isolate. Later, I pass the 100 that was divided to the other side to multiply. I have 20W. And the 20 that was multiplying my variable, I pass it to the other side to divide. So I can finally obtain the value for my variable. You can see that we have the same of the book, okay? Only that they write all the procedure, and when we pass one variable to the other side, they write it again in the same side. So maybe you can get confused, but if you solve it in this way, okay, you're going to remember this. Okay, you can finally find the value. In this case, W is equal 1,300. So the daily, we are going to complete, the daily value for calcium is 1,300 milligrams. So can you see, we have the same kind of exercise. I relate the quantities. In here, for example, I have the 260, they are the milligrams, and W is the daily value for calcium I want to know in milligrams. Later, I have the percent in here, and this is the total of the 100%. So The daily value for calcium is 1,300, and if the soy milk only has 260 milligrams, is not the daily value. Okay, we need more than 260 milligrams in conclusion. So I'm going to finish in here, guys. You already have it on the book, so you don't need to copy the problem, but I think that you understand it very well. As you can see, we don't have much time, but tomorrow we are going to work. We have the classwork, the other pages, and remember, you need to send the pages we worked yesterday, right? On Friday, you send the pages we worked yesterday. So see you guys. Have a nice day and take care, okay? See you tomorrow.